Hi, today we're looking at Functional Skills Maths Level 2. This is the PearsonEdexcel exam board. We've got practice paper 1 and we're going to start with the non-calculator section. Question 1. Bill is a builder. On Monday he made mortar mix. He used 24 kilograms of sand and 5 kilograms of cement. On Tuesday, Bill will make the same type of mortar mix. He will use 36 kilograms of sand. How much cement does he need to make the same type of mortar mix? Okay, so lots of words here. Let's try and show these with numbers instead. So we've got sand and we've got cement. And sometimes we'll have a total column. We might not need that one here, but we can put it in anyway. So we've got 24 kilograms of sand for 5 kilograms of cement. We know he's going to use 36 kilograms of sand, and we want to know how much cement will he need. So this is what we're trying to find out. Okay, and the way we can do that is by looking at this column here and how this is increasing. If we want to know what this is increasing by, well, we take the ending position of 36 and divide it by 24. Now, if we show that as a fraction, hopefully you'll see that this can simplify. And well, they're both even, so you can divide by 2, but actually you might also spot they're both in the 12 times table. So we can divide top and bottom by 12. If you don't see they're both in the 12 times table, then as I say, you can divide by 2 and you might take a few steps to get to the answer, but you'll get to the same place. So 36 divided by 12, well, we've got 12, 24, 36, so that's 3 times. And 24 divided by 12, 12, 24, that's twice. So 36 divided by 24 is the same as 3 over 2, which is 1.5. So to get from this row, or from the 5, down to this number, we're multiplying by 1.5. Or as I say, 3 over 2. So we want 5 times 1.5. Well, I'm ignoring the decimal point for now. I'll do 5 times 5 is 25. 1 times 5 is 5, plus 2 is 7. But we have got that decimal point, so we put in the decimal point there. We put in the decimal point here as well. So 1 decimal place, 1 decimal place. So our missing value is 7.5 kilograms. And we can write that in our box down here. Question 2. Write 2.71828 correct to 3 decimal places. Okay, 1, 2, 3, that would be our 3 decimal places. So we look at the next digit. If it's less than 5, well, then we can just ignore it all. If it was 5 or more, we'd need to increase this by 1, but it's, as I say, it's not, so we can just round that to 2.718. Then we've got part B here. And we're told here is a formula. P equals 3t squared. Work out the value of P when t equals 10. So we're going to substitute this value in here. So we're going to have P equals, well, we've still got the 3. When you've got a number next to a letter, it means multiply. So 3 times t squared. Well, t squared means t times t. In this case, t is 10, so it's going to be 10 times 10. And because they're all multiply, we can do them in any order. So if we ignore the zeros, we can go 3 times 1 is 3, times 1 again is still 3. And then just put our 2 zeros on the end. So we get an answer of P equals 300. Question 3. Lizzie buys 3 clocks for a total cost of £50 at a car boot sale. She sells 2 of the clocks for £22 each and the other clock for £20. Lizzie thinks she has made a profit of over 30% of the cost of the clocks. Is Lizzie correct? Right, so she's interested in the profit. Well, the profit is the difference between how much she sells the items for and how much she bought them for in the first place. Well, we know how much she bought them for, which is the £50. How much did she sell them for? Well, 2 of the clocks for £22 each. So we're going to have 22 and another 22, and the other clock was £20. So add these up. 2 plus 2 is 4. 2 plus 2 plus 2 is 6. So she's selling the clocks for £64. She bought them for £50. So if we take the 50 off the 64, 4 minus 0 is 4, 6 minus 5 is 1. She's got a £14 profit. But they're looking at the percentage. So what we could do is do 14 divided by 50 and multiply that by 100 and work out the profit that way, which is fine. But what might be easier with this is, instead of working it out, because without a calculator it might be a little bit messy, we can say, well, let's see what 30% profit would be. Well, so we want 30% of £50. And then we can compare it to the £14. Well, 30% of £50, instead of doing that, I'm going to start off by saying, well, 10% of £50, 10%, you just divide by 10. So it's going to be £5. So 30% of £50, well, 30 is 3 lots of 10. So we're just going to multiply this by 3. 3 5s, 5, 10, 15. So it's £15. Okay, so she actually made a profit of £14. She thinks she's made a profit of over 30%. Now, for her to have made over 30%, this would need to be more than 15, but it's actually less than 15. So, has she made a profit of over 30%? No, she hasn't. Let's say if you want to do it instead, you can work this out and then you can compare this percentage to the 30%. But I think this is a more straightforward way of doing it without a calculator. Okay, and question 4. This is usually the high mark question in the non-calculator section. Usha is a local councillor. She wants to write about a new housing development. The diagram shows the space for the new development. So we've got a triangle here, half a mile by half a mile. Usha thinks that the area of the development will be greater than the total area of 50 football pitches. Usha knows a football pitch is rectangular, 100 metres by 50 metres. So, do a quick sketch, 100 metres by 50 metres. And we know that 1 mile is 1,600 metres, because miles are imperial measurements and metres are metric, so we need to do some sort of conversion here. So what we can do is we can try and do some conversion, try and get our measurements all in the same units. Now I'm going to try and get everything into metres just because it's generally going to be nicer to work with. Now before we get to metres, we've actually got to try and do some sort of conversion here. So if we know that 1 mile is 1,600 metres, half a mile is going to be 1,600 divided by 2. Or if we do that using a bus stop method, so 2 into 1 doesn't go, 2 into 16, 2, 4, 6, 8, 10, 12, 14, 16. That's 8 times. 2 into 0, 0. 2 into 0, 0. So half a mile is actually 800 metres. And that's going to be the same down here. Because what we're going to do is work out the area of this, and then also work out the area of 50 football pitches and do a comparison. So the area of this triangle, or the area of any triangle, is a half times the base times the height. So in this case, it's going to be a half times the base, which is 800 metres, times the height, which is also 800 metres. So let's start off. I suppose the best way to think of it is, well, let's do half of 800. Well, half of 8 is 4. So half of 800 is going to be 400. And then we've still got to multiply it by the 800. So we've just done this bit first. Okay. Now to multiply these together, 4 times 8, 8, 16, 24, 32. And then put 1, 2, 3, 4 zeros at the end. So we've got 320,000 metres squared. Right, so what we need to do next is to work out the size of our 50 football pitches. Well, this is a rectangle now, so the area of the rectangle is going to be the length times the width, which is 50 times 100. 5 times 1 is 5, and then put our 1, 2, 3 zeros on the end. So 5,000 metres squared. But we've got 50 of these, so we want to multiply this by 50. Well, 5 times 5, 5, 10, 15, 20, 25. And then we've got 1, 2, 3, 4 zeros. 1, 2, 3. So we've got 250,000 metres squared. So will the area of the development be greater than the total area of 50 football pitches? Well, the area of the development was 320,000 metres squared. The area of the football pitches is 250,000 metres squared. This one's bigger, so yes, it will be bigger. Now there's a final mark for this question. And it's saying use reverse calculations to show a check of your answer. So we want to start with our answer and go backwards. Well, we've sort of got two answers. We've got our 250,000. That was one of the answers. So how can we go backwards? Well, to get to the 250,000, if you remember, we did 50 times 5,000. So we can divide that by 50. Well, if we cancel a 0 on both, we've basically got 250,000, and we're going to divide that by 5. 5 into 2 you can't do because 5 is bigger than 2. 5 into 25 goes 5 times. 5 into 0 is 0. 5 into 0 is 0. 5 into 0 is 0. So we got back to 5,000. That's part 1. We also need to do the other part. So we also had an answer of 320,000. And if you remember, we got that by doing a half times 800 times 800. So we can start by dividing that by 800. So we can cancel a 0 with a 0 there, another one there. So that leaves us with 3200 divided by 8. 8 can't go into 3. 8 into 32. 8, 16, 24, 32. 4 times. 8 into 0 goes 0 times. 8 into 0 goes 0 times. So we get back to 400 there. So we've done a reverse calculation for both parts. So that's the end of the non-calculator section. So let's have a look at the calculator section now. Question 1. This graph can be used to convert between gallons and litres. Okay, we've got the chart there. And they're asking us to convert 60 litres to gallons. Right, so 60 litres to gallons. Let's keep this down here so we can see. Well, 60 litres, these are our litres here. I'm going to draw a line straight up. And that meets here on the graph. So I then draw a line straight across. These are gallons. 10, it's between 10 and 15, so 11, 12, 13. Okay, then we're told one day Anaya used 44 litres of fuel. Mira used 8 gallons of fuel. Anaya used more fuel than Mira. Use the graph to work out how much more. Remember to give units with your answer. Right, so we've got these in 2 different units. We want to get them in the same units. Doesn't matter if they're both in litres or both in gallons. So what should we do? Well, we've got 44 litres. Let's maybe see what that would be in gallons. So here's 40, here's 50. Now, look, we've only got 1, 2, 3, 4, 5 squares here, but we've got a difference of 10 litres. So each of these must be 2 litres. That would be 42, 44, 46 and 48. So 44 litres, we're going to read up from here. And then read across, which is 10 gallons. Okay. So we want to know how much more. They said that Anaya used more than Mira. So I'll just show you my 10 gallons here. So I don't need to convert the other one. I just want them both the same. So it's basically going to be 10 minus 8. And that's going to give us an answer of 2. So it's going to be 2 gallons. It's really important to put the units on this one because we could work it out in litres or gallons. So you need to show which way you've done it. It would either be 2 gallons or if you've worked it out in litres, it's going to be probably about 11, something like that. I think either way would be fine. But I think this is, I don't know, for me it was easier, but you can do it either way. Okay. Question 2. David reads this advert on his county council website. 70% of the area of woodland in the county is native woodland. This means there are 350 kilometres squared of native woodland in the county. Work out the area of woodland in the county that is not native woodland. Right. So we know that 350 kilometres squared represents 70% of the woodland. Now, we want to work out what the other bit is, what the 30% is really, because it's going to be 70 plus 30 would make 100. So one way we can do this, and I think probably the easiest way is to say, well, what would 1% be? So if we take the 350 and divide it by 70, this will tell us how much woodland equates to 1%. And now we can use a calculator for this. So let's put this one over here. So 350 divided by 70 is going to be 5. So 5 kilometres squared relates to 1%. We want 30% because what we're saying basically, well, you start with 100%. If you take off 70%, then you're left with 30%. So we must have the woodland that is not native must be 30%. So if we know 1% is 5, we just want to do 5 times 30. So I've still got the 30 here, multiplied by 5, We get 150 kilometers squared. Question 3. The scatter diagram gives information about the temperatures at 8 different heights up a mountain. Okay, so at 100 meters up, the temperature would be just 1 degree there. And at 200 meters up, it would be minus 1, 2, 3 there. Okay. At a height of 1,000 meters, the temperature is minus 13 degrees. Plot this information on the scatter diagram. So 1,000 meters, that's here, and we want minus 13 degrees. So that would be minus 5, minus 10, minus 15 is down there, so minus 11, minus 12, minus 13 would be that one. Then for part B, draw a line of best fit on the scatter diagram. So our line of best fit is a straight line that goes through all the data. So here's the first point, here's the last. Doesn't have to go through any of the points, but it's got to follow the overall pattern. And we want roughly the same number of values above the line as below the line. So I'm going to do something like this. That's my line of best fit. Yeah, we've got a few lines, a few values above, a few below. That looks good to me. Now for part C, use the line of best fit to estimate the difference between the temperature at a height of 550 meters and at a height of 950 meters. Okay, let's keep that on there so we can see. So 550 would be halfway between 500 and 600, so it's going to be on here. So if we read down, it'll be there really, which read across is right. I'd say it's in the middle. So if this is minus 5, we'd have minus 6 here, minus 7 would be down there. So that's going to be about minus 6.5. Now we also are interested in the temperature at a height of 950 meters. So that's going to be between 900 and 1,000. So that's going to be here. And this one's between the boxes as well. So we've got minus 10 here, that'd be minus 11, minus 12. That's going to be minus 12.5. Okay, so we want to know the difference between these two temperatures. Well, normally the way we'd do it is we'd take the higher value, so the minus 6.5, and then subtract the lower value, which is minus 12.5. Okay. Now you might think, oh, 2 minuses make a plus, but actually you can just put this straight in your calculator. So we've got 6.5 minus, because it's a simple calculator, I have to put the negative in after the number. So minus 6.5, take away or subtract 12.5, but it's minus 12.5, and we get an answer of 6. Otherwise, if you want to think of it in terms of a number line, you can think we've got 0 would be here, we've got minus 6.5, we've got minus 12.5 would be down here. So we'd move minus 7.5 for 1, minus 8.5, minus 9.5, minus 10.5, minus 11.5, minus 12.5. So that's 1, 2, 3, 4, 5, 6, which is what we've got there. You could put your units on there, but actually because we would just put it in the box down here, they've already put the units for us. Okay, question 4. Here is a pentagon. So if you remember, a pentagon is a 5-sided shape. So we've got 1, 2, 3, 4, 5. The pentagon has one line of symmetry. Work out the size of the angle marked X. Okay, so where could our line of symmetry be? Well, I think it's going to be right down the middle here. This is going to be useful for us. Now what we can do is we can say, well, they've shown us quite nicely that this pentagon is essentially a square at the bottom with a triangle on top. If we know this full angle is 125 degrees, well, we know the right angle bit, the bit on the square, is going to be 90 degrees. So this angle up here is going to be 125 minus 90 degrees, which is 35 degrees. Now, this is where the line of symmetry comes in handy, because that means, well, this angle over here must also be 35 degrees. So we've got one angle, we've got another angle, we're trying to find this one. Well, I know the total of the angles in a triangle is 180 degrees. Well, if we've got two of them that's 35, well, that's going to give me 70 degrees. So if we take that away from 180, whatever's left must be this value here, which is 110 degrees. And we can put that in the answer box down there. Okay, question 5. Nicola wants to put a flat roof on a bike store. The roof will be made of concrete and in the shape of a cuboid as shown. Okay, so it might not be a typical cuboid, but it is. It's got rectangular sides and a rectangle for the base as well. Nicola wants to put a metal strip along two of the longest edges of the roof. Well, the longest edges are going to be this one here, and it'll also be this one on the other side as well. So it's going to be those two. She knows the density of concrete is 2,300 kilograms per meter cubed, and the mass of 1 meter of metal strip is 5 kilograms. Work out the total mass of the concrete and the strips she wants. Okay, well, we know the mass of 1 meter of metal strip. So maybe let's work with the metal strips first of all. Okay, so we know we've got 3.5 meters here. We've got another 3.5. So we want 3.5. You could say plus 3.5 or 3.5 times 2. It's going to give us 7 meters. Okay, and each of those meters, according to this, is 5 kilograms. So if we multiply that by 5, we get 35 kilograms. And that's for our strips. Okay, we need to work out the mass of the cuboid as well now. So what we're going to do for that is work out the volume of this shape first of all. Now, we've got our measurements in meters cubed. Now you might remember that the volume of a cuboid is the length times the width times the height. But they need to be in the same unit. So we've got meters, but this is in centimeters at the moment. So to turn it into meters, we're going to need to divide it by 100. So 12 divided by 100 is going to be 0.12 meters. Now we can multiply these all together. So now we've got the length, 3.5, the width, 2, and the height, remember, 0.12. So we're going to get our volume. I'll multiply them this way. So 0.12 times 2 times 3.5, because it was already in my calculator. So we get that the volume is 0.84, that's meters cubed. Okay. So we've got to think, well, it's 0.84 of a meter cubed. We still want to work out the mass. We haven't got the mass, but we have got the volume, and they've also told us what the density is. So using this formula, if the density is the mass divided by the volume, well then the mass must be the density times the volume. Okay, you can think of it with these triangles. Mass is on top, so we've got mass, and then we've got density and volume at the bottom. Okay, so let's use this. The density, we're told, is 2,300. And the volume, we've worked out, is 0.84. So actually, so it doesn't get too messy, let's bring this down here. So 0.84 times 2,300 gives us a mass of 1,932 kilograms, and that's for the cuboid. We want the total mass. Well, the total mass is going to be the mass of the cuboid that we've just worked out, plus the mass of the strips, which was 35 kilograms. So if we add these two together, we get 1,967 kilograms. Question 6. Mai has this information about 100 flowering plants in her shop. Okay, so we've got the stem length, and we've got the split between short and long, and we've got the size of the flower split between small and large. So in other words, we've got 10 flowers that have got a short stem length and a small flower, 18 with a long stem and a small flower, 43 with a short stem and a large flower, and 29 flowers with a long stem length and a large flower. She will take a plant at random from these plants. Work out the probability that this plant will have a large flower and a long stem. Right, probability, always good to do them as a fraction if they haven't told us what format to write them. We're picking a plant from random from all of these. Well, they've told us there's 100, so our denominator is going to be 100. That's the total that we've got to choose from. We're interested in the ones that have got a large flower and a long stem. So large flower, they're the large ones, and the long stems are those. So we want this number where it overlaps. So it's just going to be 29 out of 100. We can write it in the box. Mai will take at random a plant from the 72 plants that have a large flower. Work out the probability that this plant will have a short stem. So we're only interested in the 72 that have a large flower. So I can write it right in here. It's going to be out of 72. And we want the ones that have got a short stem. So these are the 72, the large ones. We only want the plants that have got a short stem. That's 43. So it's going to be 43 over 72. Question 7. Sal works in a dress shop. She wants to know how well the labels on the dress hangers agree with the true size of the dresses. The table shows information about some hangers and dresses. Okay, so for example, here we've got 8 dresses where they were labelled as 10 and they really were 10. So that's great. We've got 2 here that were labelled as 10 but were actually 12. Okay, and we can read that for all of them. We've got nothing here, so we didn't have any that were labelled as 12 and were actually 10, so these are just zeros. Sal thinks that 2 in every 7 dresses are on hangers with the wrong label. Is Sal correct? Okay, well, what's going to be helpful is let's see how many dresses we've got in total. So we can use these totals down here. Let's see if we add these all up. It'll tell us how many we've got. So we've got 12 plus 13 plus 19 plus 16 plus 17. So we've got 77 dresses in total. We're interested in the ones on hangers with the wrong label. Well, all the ones that are on the right label would be where it's 10 and 10. So that would be right. 12 and 12. That'd be right. 14 and 14. 16 and 16. So these ones are all okay. We're interested in all the others. So we've got 2, 1, 1, 3, 1, 2, 2, 1, 1, 1, 2, 1, 1, 2, and 1. So let's add these all up. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So the wrong ones are 22 out of 77. Well, let's see, can we simplify this at all? Well, having the same numbers, 22, I know that that's in the 11 times table, and so 77. So if we divide these both by 11, 11 goes into 22. Well, actually, let's just use the calculator. 22 divided by 11 is 2, and 77 divided by 11 is 7. She thinks 2 in every 7 dresses are on hangers with the wrong label. Well, 2 in every 7. Yes, exactly what we've just worked out. Question 8. James has a contract to paint 30 identical water tanks. He has to paint the outside surfaces of each tank, but not the top. Each surface is rectangular. Okay, so we've got a front, we've got a back, we've got the 2 sides, we've got the base, but not the top. James knows that 1 tin of paint is enough to cover 12 metres squared of surface and costs £26.99. Work out the total cost of the tins of paint he will need for all 30 water tanks. So we want to work out the surface area of this. Okay, so let's split it up. So we're going to have a base. And the base is going to be 1.1 metre by 0.8 metres. Use the calculator here. 1.1 times 0.8. Get 0.88 metres squared. Now let's do the sides. So here and here. Well, it's going to be 0.6 times 0.8. But we've got 2 of them, 1 and 2, so we can multiply that by 2. So 0.6 times 0.8. That would be the area of one side, multiplied by the 2, gives us 0.96 metres squared. Now let's do the front and the back, because they're going to be the same. Front and back. So this front rectangle, well, it's 1.1 metre by, that's going to be 0.6. And again, because we've got 2 of them, we'll multiply it by 2. 1.1 times 0.6 times 2, 1.32 metres squared. So how much have we got in total? So we've got a 1.32 plus 0.96 plus 0.88. So we've got 3.16 metres squared. That's for one of these water tanks. We need to paint 30 of them. So we've got 30 times 3.16. And that gives us 94.8 metres squared. Well, we also know that 1 tin of paint is enough to cover 12 metres squared. So we want to divide this by 12, and it's going to tell us how many tins of paint we need. So 94.8 divided by 12, 7.9 tins. Well, it's unlikely that they will sell you 0.9 of a tin, so we're going to need to buy 8 tins. So we want 8 tins at £26.99 each. And that's going to cost us £215.92. Andros has an oil-fired heating system. In a 30-day period, he used a full tank of oil at a constant rate per day. At a different time of the year, the amount of oil Andros uses per day is 1/3 of the rate used in the 30-day period. How many days should a full tank of oil last at this new rate? Okay, so he's using less, so it should last for more. So we're expecting our answer to be more than 30. Well, if it's only 1/3 of this, well, we almost want the opposite of that. If it's reduced by 1/3, well, then it's going to increase the amount of time it lasts for by 3. Because we're sort of putting the 1/3 on its head. So that means that we would have, if you think of the thirds, we'd have 30 days, and another 30 days for the second third, and another 30 days. So 30 plus 30 plus 30 is 90 days. So again, you can sort of use a bit of reasoning, a bit of logic to think that one through. So we're using 1/3 of the oil, so it's going to last 3 times as long. And then we've got a part B to this question as well. Use reverse calculation to show a check of your answer. Well, we did 30 plus 30 plus 30 is 90 days, but you could also think of that as 3 lots of 30 is 90 days. So we can do it in reverse. We'll start with the 90, we'll divide it by 3, and it takes us back to 30 days. There's our check. Question 10. Lena recorded the number of late trains at a station in a day over a period of time. She shows this information in a diagram. So we've got number of days, number of late trains in a day. It's really important with something like this, before you try and go straight into the question, try and understand what it's saying. So what we're saying is, we've got number of late trains in a day. So this means there was 1 late train. So there were 2 days where there was only 1 late train. There were 1, 2, 3, 4 days where there were 2 late trains, and so on. We're told, for this information, work out the median number of late trains in a day. Right, so usually we see these numbers all sort of like laid out in a line instead of a, sort of presented like this. So what we want to do is get them listed out in a line. So we're looking at the number of late trains in a day. Well, there was 1 train late, but there were 2 lots of those. There were 2 days, so we've got 1, and there was another time when we had a 1. There were 2 trains late on 1, 2, 3, 4 days. So we've got 4 2s. 3 trains late on 1, 2, 3 days. So 3 3s. 4 trains late on 2 days. So we've got 4 and a 4. 5 trains late 2 days as well, 5 and a 5. 6 trains late only once, so only 1 6. No days with 7 trains late, none with 8 late, and 1 day with 9 trains late. So if we want to work out the median, we're going to ignore the first and the last, second and second to last, keep crossing them off in pairs until we end up with either 1 or 2 in the middle. In this case, we've just got 1 in the middle, so that's our median. Then Lena says the median number of late trains in a day from this information is a good estimate of the average number of trains late over the period of time. Is Lena correct? Explain why you think this. So there's various answers you could give. So long as you're giving a good justification, it's fine. I'm going to say, well, if we look at these values, one of the benefits of using the median is it ignores some of these sort of extreme values or these outliers over here. So I'm going to say, yes, it's a good estimate because it ignores extreme values. I'll put in brackets outliers. You could also give the same argument but say no, because it doesn't include these values. As I say, it's the justification that's important, but it's just worth 1 mark, so don't spend too much time thinking about it. Question 11. Joanna is a landscape gardener. She has to fill a circular space with flowers. Okay, so we've got a circle here. We've got a radius of 4.5 metres. The radius of the circle space is 4.5 metres. Joanna will plant 40 flowers per square metre of space. She will plant 4 times as many red flowers as white flowers. How many red flowers will she plant? Okay, well, let's work out how many plants there are, or flowers there are in total, first of all. So, and to do that, we want to know how many metres squared. So in other words, we want the area of the circle. And the area of a circle, we can use the formula pi r squared, where pi is 3.14. And if you can't remember, it's always written on the front of the exam paper. A letter or a symbol next to another one means we multiply. R is the radius, 4.5, and it's squared, so it means it's multiplied by itself. So 3.14 times 4.5 times 4.5. So we've got 63.585 metres squared. Joanna will plant 40 flowers per square metre, so we can multiply that by 40. That gives us 2,543.4, but you can't really do plant 0.4 of a flower, so let's call it 2,543 flowers. Okay. We know that she's going to plant 4 times as many red flowers as white flowers. So we can do a little table here. We've got red, we've got white, and we'll have our total. So we've got 4 red for every 1 white. Well, if that's all we had, that would be a total of 5. But actually, we've got a total of 2,543 flowers. So we want to say, how are we getting from the 5 up to the 2,543? And the way we do that is to do it in reverse. So we say 2,543 divided by 5. and that gives us 508.6. So we want to multiply that by each of these values. So this one times 508.6 and the 4 times 508.6. Well, times 1 is just going to be 508.6 times 4. We get 1,200. No, that's not going to work, is it? Oh, I did divide it by 4. I want times 4. Sorry, times 4. Gives us 2,034.4. Now, because these are plants, I'm going to round it to a whole number. So we'll have 2,034 red plants. And this is going to round up, so 509 white plants. But they were only asking us about how many red flowers. So we'd have 2,034. There we go. And finally, question 12. Jim owns a small business. The table shows information about the weekly wage of the 40 workers. So 10 workers receive £320 a week, 13 workers receive £370 a week, and so on. Jim wants to increase the mean wage by 4% plus £10. Jim thinks the new mean weekly wage of these workers will be more than £415. Is Jim correct? So we're going to work it out. So we want to start off by working out the mean wage. Well, if we've got 10 workers, well, actually, let's say for the mean, we want the total, and we divide it by the frequency. But the total what? Well, it's going to be the total weekly wage. So to work that out, well, if we've got 10 workers receiving £320 a month, we're going to work out what that is in total. And we're going to do the same for this, and this, and this, and this, and then we'll add them all together, and that's going to give us our total weekly wage. So 320 times 10 is 3,200. £370 times 13, 4,810. 420 times 8 is 3,360. 470 times 7, 3,290. And 520 times 2 is 1,040. So let's add these all up together. I'll do them from bottom to top as I've got this in here already. So add on 3,290 and 3,360 and 4,810 and 3,200. This gives us a total of £15,700. Right, so £15,700. The frequency, well, how many workers have we got? We can add these up, but we know that there's 40 workers, so we can divide that by 40. So we get 392.5, but because it's money, that's going to be 50p. That's the mean amount. We want to increase this by 4%. Right, so you can work out 4% of this and add it on. I'm going to do this. I'm going to say, well, we want the original 100% and we want to add on 4%. So in other words, we want 104% altogether. So if we're increasing that by 104%, we're going to do £392.50 times 104 divided by 100. So instead of working out the 4% separately and adding it on, we're just working out 104% in one go. So if you don't like this or you're not comfortable, work it out the other way and you'll see you get the same answer. So this takes us up to 408.2, which would be £408.20. We need to add on £10 as well. So let's do that. And we get £4,118.20. And that is more than £415. So is Jim correct? Yes, he is. And that's the end of the paper. So thank you for watching. Hope you found it helpful. Please subscribe to the channel. Turn your notifications on so you find out when I upload more videos. Good luck if you've got any exams coming up soon. And I look forward to seeing you again soon. Thank you.